Hi everyone, so what we're going to be doing today is we're going to be going through and we're going to be checking off some of the basic of the electricity to make sure that everyone's on the same page as far as understanding what's going on there. And then what we're going to do is we're going to dive more into the code. I want to make sure that you guys understand exactly what this code is trying to do and how we implement our use of functions in order to make our life easier for coding itself, and especially with the robots. So here we go, talking about some of the basics. So some of you guys should know this pretty well, and some of you guys may not. So electricity, at its very basic, when we take a look at it, is defined as that flow of electrons. So if we look at, say, atoms, all right, let me pop it up over here. Let's do a little drawing right here. So when we're looking at atoms itself on the very basic small level, we have a nucleus, and in the nucleus we have what we call protons and neutrons. Protons have a positive charge, neutrons have a neutral charge. And then all floating around the outside of it, well, it's a little more complicated than that, but floating around the outside, we're just going to say, are our electrons. Now, the electrons are much, much smaller in mass than these items are right here. So what that means is the electrons, these little guys right here, are the ones that like to move pretty easily. So if we have the right type of atom, like say, copper. Copper actually is a type of atom that has a really easy time sending these from one atom to another. All right. And when we have the flow of these electrons moving through charges, or moving through wires or conductors or anything like that, we call it electricity. Now, this electricity is, as these electrons are moving, they can actually transfer energy. Much the same as if we were dealing with, say, water going down a river. As the water goes down a river, if we put something in between that current, like say a water wheel, it's gonna do some work. So in this case, if we have electrons that are moving through a conductor and we put something in the way, like say a light bulb, or in our case with the robots, a motor, it's gonna get moving. Now, there are three main basic kind of ideas behind electricity that we need to know in order to understand what's going on with our robots. First is the idea of voltage. Now, a lot of times you guys have probably heard of voltage before, but what you need to know is that what it is essentially a charge difference. What means we have more electrons in one area than we do in another. And when we have this charge difference, it's like the same thing as having a ball on top of a hill versus that ball being on the bottom. It's going to have a difference between the two in height. And so there's a potential for it to flow. So because of that, we also call voltage potential. All right? Because it has the potential for those electrons to go somewhere else. If we think about basically anything in the universe is always striving for equilibrium itself. So if you have uneven electrons, those electrons are going to want to go where they can even it out a little more. Generally, with every atom, you want to have the same number of electrons as you have protons. That way there is going to be no charge whatsoever. So voltage itself is the potential. Technically, it is the potential energy per electron that a source can provide. And the source is just going to be a battery. In our case, we're going to be providing the voltage source through the Arduino board itself, which is coming from a battery. Now, this is the symbol we typically use for a battery or a voltage source. You'll notice right here there's a positive side and a negative side. If you look at your batteries, you typically have the same exact thing going on there. And an easy way to remember it, if you don't have the plus and minus drawn on these symbols, if this is longer, it's positive. If it's shorter, meaning there's less of it, it's negative. All right? Now, voltage is measured in volts. So on our boards, you're going to be noticing all along it, most of the pins output 5 volts, although there are ways we can actually jump up that voltage itself. Outlets in our house are typically 120 volts, so the ones we see all around the school for the most part are 120 volts, although there are some that can go higher. And it's always measured across 2 connections, so you always need to have 2 connections in order to have a voltage difference. The same thing as when you're measuring height. You can't just go off and say, oh, the height of this mountain is 2,000 feet. You need to know what you're referencing that 2,000 feet to. most of the time it's going to be sea level. That way we have right next to the sea, the top of this mountain, the difference between that height is going to be 2,000. It's kind of the same thing as voltage. You're going to take basically a sample at one spot, sample at another, and you're going to find out the difference in potential at those two spots. Next thing we need to understand is the idea of current. So when electrons flow, we have current itself. More current, more ability to do work. All right, and current is defined as the rate of flow of electric charge and is actually measured in amps. So this is the sort of thing that can cause damage. If you have a lot of current, say going through your body, it can hurt you pretty badly. It can give you burns. It can eventually kill you too. But current itself is one of the things we're going to have to worry about with our robots. For the most part, these robots have been set up such that the current is going to stay pretty low when they go through the motors or they go through the sensors. One of the things you do have to worry about, though, is that if we accidentally short circuit any part of it, which means you put a wire between two spots that there shouldn't be, which has happened to a couple of robots already, that short can cause a burst of high current, and that high current can kill a motor or kill a sensor or stuff along those lines. Last thing is resistance. So there's this guy, George Ohm, he discovered that voltage and current are related through something called resistance. Basically, all it means is it's defining how hard it is for that electricity to flow. And this is usually defined by the motor, by the light bulb, by whatever we're plugging in there, how high it's opposing the current to flow through there. We're not going to get too much into this right now. We'll deal more with this when we start dealing with electromechanics with our next robots. Units for resistance are going to be ohms, and they're written as this little horseshoe shape. There is a relationship between them. We call it Ohm's law. Again, we're not going to be dealing with this right now, but just want you to be aware of it for later on. So here's just another way of kind of trying to look at it. Our voltage is kind of like the pump in a water system. It's going to provide some sort of pressure, some sort of potential difference. If we have shells in the pipe or anything that's slowing the rate of flow through it, that's the same thing as like having a resistor or having a light bulb or a motor in there. It's going to slow down the ability of that current to move through. And the electric current flow is the same as just like the rate of water flow as we go through there. Alrighty, let's get back to our Arduino itself. So this image right here is, again, showing us what the Arduino looks like. Again, we're using the shield, so it doesn't matter as much, but what we do care about is we do care about these ports. All right, because we have to tell our Arduino program what ports things are plugged into. So over here you can see we have all the pins, 0 through 13. These are digital pins. And over here we have A0 through A5. These are analog pins, which we're going to talk about a little later on. So when you're calling out, say like IN1 is pin 7, this is what you're meaning. You're meaning that pin 7 is connected to IN1 on the motor control board. All right, we're just trying to call out specific things for it. So again, as we're looking through this, remember the bare Arduino code. I can talk this morning. The setup is essentially where you're going to be telling the program once where your pins are connected to. So this is where you're going to be telling, you know, pin mode such and such is connected to this, and it's an output, or this is an input, stuff like that. Your loop is where it's going to run repeatedly. Now, a couple of you guys have made this mistake already. Make sure you only have one void set up in your program. Make sure you only have one void loop in your program. If you have more than one, programs are going to get confused because it's going to try and say, hey, I'm going to run this loop forever, but there's also this other loop that wants to run forever too. And at that point, the program is going to go, or the compiler is going to go, nah, this doesn't make sense, error, and it boots it back to you to fix it. Now, this right here, again, is a basic set of code. Most of the code that I'm giving you is going through, and it's going to have comments in it that tell you what to do. Now, if you look at this, basically we have to understand the three major parts here. The first major part is this first section. This right here, again, we're using this define function, it's defining what we call macros. These are where the pins are located. All right, so IN1, IN2, IN3, IN4, ENA, and ENB. These are all the connections on the motor control board. All right, and so what we're doing is we're labeling where these are plugged into on the Arduino board itself. So first thing we have to do is we have to define all of these. All right, we want to do those first. That way when you call out those letters later on, it knows what you're talking about. So when this calls out ENB right here, what it's actually doing is it's replacing this with the number 5. When I say IN1 right here, it's replacing IN1 with 7. That's all it's doing. Second section is the setup section. Again, this is where we're declaring all the pin modes. All right, so this is where we're telling the program, all right, pin number 5 is going to be an output. Pin number 7 is going to be an output. Pin number 8 is going to be an output. And if we had any sensors, we'd say, hey, instead of output, it would be input. But we'll get to that later on. And then sometimes there are some universal settings that are going to vary by program type. For the most part, I'll tell you what those are. For this program itself, you'll notice there's 2 of these, what they call digital writes. It's just setting ENA and ENB to high. What that's essentially doing is ENA and ENB are the speed controls for the left and the right side motors. And so this is just saying, hey, whenever we call out those motors, we're going to run them at full speed. All right, that's all this is saying right here. Last part we're going to look at is the third section. This is, again, this loop section. This is what's going to run through what the Arduino is telling the robot to do over and over and over again. And in this case, we can see we have a lot of digital writes. The digital write, again, all we're doing is we're saying, hey, IN1, which is 7, so pin 7 is going to be set to high. That means it's going to output 5 volts. IN2, which is pin 8, so pin 8 is going to be low. That means that's setting it at 0. And et cetera, et cetera. You'll notice for this program, though, it's a little funky in how it has it all written out. I'm just kind of giving you guys this for the time being, mainly because the way that the motor control board is a little different. What we're going to do, though, is we're going to be trying to take a look at a better way of doing it. So this right here, again, is that void loop. This is how you would write it out using the basic code, the basic method, to say go forward, stop, go back, stop. Using 4 lines of code to tell something to go forward is kind of dumb, especially when we start getting into coding the robot to do a lot more. Like, say we want the robot to go through a maze. It's going to be a lot of stuff that it needs to do. We can actually rewrite the entire thing just like this. Forward, delay, back, delay, left, delay, right, delay. This right here will do the same exact thing as this. So, which one's easier? Hopefully you already understand that it's going to be this one on the right here. Now, way we take a look at this. Let me close this out right here, and I'm going to pull over 2 different programs and kind of walk you through it. So here is the simple program, and here is the old program. Alrighty. So this program on the left is the one that we've been doing already. Up here, these are what we call truth tables. I haven't been showing them to you guys, but it essentially just tells us what IN1 and IN2 has to be in order to get the motors to do certain things. So these are all just comments just meant for humans. So this right here is the bulk of our code itself. All right. So at the very beginning, you'll notice this code right at the very beginning is the same as this code right here. There is no difference between this. We're basically testing out, or not testing out, we're showing what the pins are connected to, and we're setting the same macros, those same variables, to be used throughout the program. Now you'll notice, next part here is something called void setup. Over here, though, is a little different. Before we even have the setup, we have these 4 things that are called out. These are called functions. All right? These functions are, I'm basically writing them in this, and I'm giving them to you guys. what each one of these functions is doing is it's defining what it means for the robot to go forward, what it means for the robot to go backwards, what it means for the robot to go left, and what it means for the robot to turn right. So essentially what we can do is if I write this void forward and add all this code in here, again, this code right here is going to be the same exact code that you see over here in the loop that tells it to go forward. It's no different. All right? Only difference here is you notice I put the ENA and ENB, turning them on inside the loop right, or the function right there. This right here, the void backward, you'll notice these 4 lines of code are the same as when your robot's going back over here. So all I'm doing is I'm just putting in the code to go forward, backward, left, and right in these. And what that means is later on in the program, if I want the robot to go forward, I just type in forward, these 2 parentheses, semicolon, and it's going to set the motors to do what's in this loop right here. So this is what it's going to set whenever I call out forward down here. Whenever I call out back, it's going to look up here and go, hey, run this code now. And the same thing if I do left and right. All right. The one thing you notice I don't have in here is I don't have stop, but that's okay because we're going to learn how to do that a little later on. Basically what you would do is you would write the same exact type of code, except what you would do is over here, you would put in this code rather than this over here. One of the things you will notice is the void setup. They both do still have void setups. You always need to have that void setup. Here you can see it's pretty much the same exact code. The only difference is these 2 digital writes to turn on the speed of each side to high. Over here it's located in each one of the individual functions rather than the setup. Either way, it doesn't matter. You could actually run this program like that as well. Hopefully this gives you guys a little more background into what's going on there. If you have any questions, let me know. Have a good day, guys.